Okay, so let's just get more time.
So, all right, here we go. And it's actually going to record up here out today. All right, so these are the same, or we're going to prove that. We're going to prove that. Okay. So, what are we given? M is on AB, and PM is perpendicular bisector, meaning it cuts AB in half, and of course, is perpendicular to AB. So that therefore, PMA and PMB are both 90 degrees, and of course, AM equals MB because you're cutting this something in half. It's just a definition of segment bisector, because you could also have an angle bisector, so we have to be a little more clear about that. PM equals PM. Why do we call that? Good, reflexive. All right. And then probably going to do something with triangles, right? I mean, that's the whole point of what we've been doing. So what triangles are the same? Go ahead, Connor.
APM.
Yeah,
BPM.
good. And you said it in the perfect order. What's your reason? Correct. Good. Yeah, because you know that PM equals PM, right? Good. So triangle APM. Good. You guys are very solid with this. BPM. And then lastly, we could say that PA is congruent to PB, and that's CPCTC. So why do we do this? What was the reason for this? Here's the reason for it. What we just proved is that any point on a perpendicular bisector is of equal distance to the endpoints. So I go ahead.
Bisector.
No. Yeah, yes, but is of equal distance to the endpoints of the segment that is being bisected. And that's a little long-winded there, but that's what we just proved.
So I took point P, which is not an AB, right? So point P is like some point off on the under, right? And if I draw a line through P in such a manner that it perfectly bisects AB, then I can say that P is an equal distance to those two endpoints. That's what I just proved. So it'll always be true for perpendicular bisectors.
So if I pick another random point, like say up here, and try doing the same thing, is that going to be of the same distance? Say I call it like point Q. Is Q the same from A to B? Yeah, it will be. So that's the thing, and we can now go with that. So questions on that one? No? And looks like you guys are really good with doing the triangle proof. So if you were fine with like proving the triangles are congruent doing CP, you'll be fine for the quiz today. You'll be A-okay. Because that's pretty much what it's like. Let's look at another one here. Um, this one will just kind of just write it out. As Sergio was drawing shapes on his paper, he drew a line segment that connected midpoints. Okay. So this is called the mid segment. Brainstorming the team was the relation between DE and AB. Ooh, that's a good one. I like this one. Let's be hypothetical. That's usually a good way to make connections when you're hypothetical. Give me a number for a length of CD. How long do you want CD to be? 5. So DA also equals 5, right? And what does CA equal? Okay, good. Okay, what about CE? Give me a number of CE equals.
7.
Okay. Surprised you guys didn't 6, 7. All right. So it's getting old, I know. So EB also equals 7. So what does CB equal? Perfect, good. Okay. So if I draw these two triangles, so this we'll call DCE. This is usually a good strategy to help you understand why things are true. is come up with numbers, be hypothetical. And of course, this is 5 and 7, 10 and 14. Okay, what do you notice about the top angles for each of these triangles?
Angle DCE and angle CCB. They're fair, right? They're the same.
So what's true about these two triangles? Go. Not congruent, but similar, right? So we know that triangle DCE is similar to triangle ACB due to SAS similarity. Therefore, what's the ratio of DE to AB? Yeah, it has to be 1 to 2.
Wait, isn't SAS also congruence frame?
Yeah, but we're doing similarity here. Yeah, there's a similarity. Remember, there's three similarities: side proportionality. There's SAS proportionality, and of course, there's AA. Yep. They're parallel. Yes, they will be parallel. Actually, first thing we'll say is this: what's the relationship between D and AB? That right there. So when asked for the relationship between DE and AB, DE is half of AB. Also, DE, right, which Connor just said, is parallel to AB. And that's because these angles are also the same. Why are those angles the same? Remember, I'm trying to remember this one carefully. Corresponding angles of similar triangles are congruent. So because we have those the same, I know we have to have DE parallel to AB. And I think that's pretty much all we wanted to say for that. So whenever you have a mid-segment, expect this to happen. Whenever you have a mid-segment, expect the mid-segment to be half of the base of the bigger triangle and expect them to be parallel. Because what's going to happen is that once you've proven the similarity, we know the corresponding angles are congruent as well. Hence, corresponding angles for parallel lines, right? So, all right. Any questions on 103? So again, it's all just understanding these relationships. That's all we're trying to do here. All right, let's move on to last page. So a little exploration before we do the poster proof. Examine trapezoids. Okay, a trapezoid. You might have forgotten. A trapezoid has just one pair of parallel sides. This is kind of special because how do the non-parallel sides appear to be related? Notice that angle H is congruent to angle G. What do you think we can deduce from that? What do you think it appears to be happening?
Like the two triangles.
Yeah, we do. EH is going to equal FG. That's for sure. When this happens.
Wait, for a trapezoid, are those angles like always?
No, not necessarily. This is special. So, what was that? Sorry. No, it's called isosceles. So you have two sides.
What would three sides be?
Just nothing. No, it's still isosceles. I don't know.
How do you know?
You just call. I mean, you could have EF equal to FH and FG. That's possible, but we don't worry about that. It's not anything that we give a special label to.
Wait, how do you know? Angle A is here again. Angle
G. We're told that.
No, I know, but then how do you know when you how do you know that
we're gonna get there? We're gonna prove it.
that the two sides are?
We're gonna prove it. We're not there yet. We're gonna prove it. That right now we're just exploring. That's all. We're gonna prove it. So anyhow, we have parallel sides, EF and HG. We're told that angle H and angle G are the same. So apparently, if that's true, then we're saying EH equals FG, but we have to prove it. So you have to write a conjecture about the side lengths. So conjecture is basically like an if statement, like a theorem or a theory. If the base angles of a trapezoid are congruent, then the non-parallel sides are congruent. I want to be careful when saying opposite sides because what would really be opposite? It's kind of weird with a quadrilateral. So I want to be careful how I made my statement. So the base angle trapezoid are congruent. Oh, then, yikes. Sorry, that was terrible grammar. So that was a fragment. Then the non-parallel sides are congruent. There we go. So now we have to prove it. So we can go bullet point format here. So what we could say is that we know that EF and HE are parallel. We also know that angles H and G are congruent. So that's given. Then we know that angles JF and angle H are congruent, as well as angles JFE. And I'll stop so you guys can copy. JFE and G are congruent due to corresponding angles being congruent for parallel lines. That's quite a mouthful there. Okay, does that make sense though?
You're told EF is parallel to HG. So H, and also we know H and G are congruent. Then we know that angles JF and H are congruent, as well as JFE and G are congruent, because corresponding angles are congruent to parallel lines.
We talked about that in the past. And let me extend this just a little bit. A little more space. Okay. So far we're okay? Everything makes sense so far? Okay, cool. Then what we could say, because H and G are already the same, we know that JH yeah, this gets a little tricky. Let's select it. Here we go. Also, we know that angles JF and JFE have to be congruent since both of them are congruent to angles that are congruent to each other. Sure. It's a little confusing the way I wrote that. So JF equals H, right? JFE equals G, right? Aren't H and G the same? If H and G are the same, wouldn't JF and JFE also be the same? Because they're both equaling things that are same. Like, what if H and G were both like 70, right? If H and G are both 70, aren't JF and JFE also both 70, right? that make sense? So that's basically substitution, what we just did.
H and G are all
EF, sorry.
angle like E, F, H, and
EFH. We're not doing EF.
I wrote like J, E, F,
And JFE.
E, H, and G are all.
All four of these, yes. Correct. Right. I know what you're saying. So then we know we're almost gonna drive this home here. I am too. Sides JH or JH equals JG and JE equals JF due to isosceles triangles. Due to them being part of isosceles triangles. That's because the base angles are equal. Right? Whenever the base angles are equal, we talked about this in the past.
The reason previous knowledge, right? These are the same, the side opposite are the same. Likewise with these.
So my last statement. It's my last statement. It's the last one, I promise. Then EH equals FG if we subtract JE from JH and JF from JG. That's called subtraction property of equality. Because if you take JF away from JG, where are you stuck with FG? If you take JE away from JH, you're stuck with EH. And those have to equal each other as well. There we go. Like, for example, what if JE were 4, then JF is 4? What if JH were 10, then JG is 10? So if you take the difference, you get 6 and 6. So again, it's just like trying to be hypothetical and making up numbers. So that's what's happening there for that one. Okay, cool. Then last one. Another special trapezoid, and then we could do poster. Consecutive angles. Those obviously on the same side of the polygon. Examine the quadrilateral right two consecutive right angles. What do you think is true about AB and DC? So what would you guys say about AB and DC? What's the relation between those two? They're parallel again. Yeah, good. AB is parallel to DC. So my conjecture would be this. If two lines are both perpendicular to the same line, then those two lines are parallel. Actually, I want to add about 3 more sentences to that conjecture. I'm just kidding. Just kidding. No, the conjecture is this. If two lines are both perpendicular to the same line, which they are, they're both perpendicular to AD, then therefore we expect the lines to be parallel. So how can you prove it? I'm just going to kind of just give you a very quick way of proving it. We know that lines are parallel when same side interior angles add up to 180 degrees. Angles A and D do that. I could have given you like 4 or 5 more bullet points in interest of time. I'm just gonna tell you straight what's going on. So we know that lines are parallel when the same side interior angles happen. That's what's happening. A and D are same side interior angles. I mean, again, I could have done more formal proof. I'm not going to do that. And then the quadrile you worked with is called a right trapezoid. Are all quadriles right angles? Um, well, yeah. Why would it not be? I think. Pretty sure. I could cheat and look at the Schoolgy notes. I'm pretty sure. Class handouts. This is 725. Yeah, you're good.
Hey, this is like a very random question, but it was in my head.
Yeah, please. I love random questions.
Teachers like learn the curriculum before they like teach it, or do they just like go off their head?
Well, you should know your curriculum. I mean,
Like, did you like before this class?
no, I go off my head.
Really?
I do. Yeah, I go by the fly. Yeah. Yeah. I do that. Yes.
Look it over, you're like, okay, this looks.
No, but I should be. It says no though. Now I'm curious. Okay, why am I wrong? I know, right? I'm being recorded. If there are only two consecutive right angles. Okay, hold on a sec. Just call it are all quadrilaterals. I didn't read correctly. That's my fault. See, this is why I gotta be in geometry. Now, okay. Yeah. Um, yeah. So that's not a yes. Okay, are all quadrilaterals with two right angles? Not necessarily. Because you could have a rectangle has at least two. Actually, a kite would that make sense?
Circle is in, scaphoid, right?
Yeah, hold on. Yeah, no, yeah, a kite. That's a good example. Wait, no, is that true?
What about a square?
Or all with two right angles. They say consecutive. Okay, not necessarily. Must be. Okay, I got you guys now. Must be consecutive, and just two.
What's consent?
Next to each other.
Oh,
Yeah, it has to be. Yeah, I'm trying to figure out how that would look, but anyhow. Okay. So we'll stop there for today. All right. So we could do a couple things. We could start the quiz now if you guys want. The poster, we could. The poster should be pretty quick. Actually, do you guys want to do you think I would help you guys for the quiz to do the poster to work? Yeah, let's practice that. Okay. So we'll get that on pairs, the poster. No, we'll use those first.
Yeah.
Yeah, say that. We got an odd number. We'll do groups of three. Or actually,
You should do it alone, or like we should choose to.
no, it's not on that poster paper. That's why. Actually, we'll do groups of three. So, actually, okay, that is group of three. What you'll join Cam and Faith. I'll join Papa. Here's Here we go.
thank you.
Okay, so this is what you're proving. Everyone's got. Here's the poster.
Wait, so people were fighting in school. I was like, how do you extend the traffic?
Yeah, no, like it's stuck behind the cars.
Oh,
Does that make sense?
yeah.
And I can't like
Yeah, 'cause
go,
you can't like go in between the
I can't
cars.
go in between them because there's like the construction, like trucks. Yeah.
Get over it.
Those nails like that. It's like crazy.
You wanna send me?
How long was I doing?
Yeah,
it?
actually,
Those nails were-
get Marcus over there.
Yeah, that's fine.
You're not.
Okay, but you're attacking me. You're in first. We're just like waiting in like as a bike as if you're
I'm gonna have a look at these.
Yes.
Yeah.
He's like,
Well, and then his dad let me like go through. Go through. Well, I like going behind the Teslas because they don't have gas. And then,
oh my god. Oh wait, that's
yeah.
I would never think that much. That cannot be.
This print.
And it was fairly.
Oh, that. Okay, ABC program, A is complete. Is congruent. It's just. Okay, so we have to prove basically just that.
Should we do it on here first?
Yes. That was wise. Okay, so then that means that.
And so you got ABC program, A is same as B. Trying to put CD is going C. Okay, cool, right.
Wait, so do I just have to, we have to prove like. This stuff, but there's no other triangle.
So what you could do is you could put these two angles are the same, so those two sides are the same. So you want to put these two angles are the same.
Got it, okay.
D equals C equals CB equals C. Oh, should I just put this side also as my basically?
Yes.
Oh.
We just need to prove that this angle is like the same as